Okay, welcome everybody to our session called a 21st Century Lunch Bell. My name is Thomas Goelles. I work for a company called Solvion back in Austria, based in Graz. I'm an Office 365 MVP, team lead, responsible for everything in our company. Development SharePoint, infrastructure SharePoint, development Office, infrastructure, AI with my colleague here, and back home I run SharePoint Saturday Vienna, a local meetup in Vienna and a local meetup in Graz.
Hi guys, my name is Stephan. I'm also working at Solvion in the same team. Tom is my team lead. I'm doing at Solvion basically Office 365 and Azure infrastructure services. I'm a technical lead there, and apart from that, I'm a Microsoft MVP for AI. So everything which is part of the AI stack at Microsoft, like bots and cognitive services, is my area.
Okay, thanks to the great sponsors that make this or such events, not only this, but every community event possible. Go visit their booth, listen to them, look at their products. Most of the times, if you have the question of make or buy, choose the buy way. Believe me, I'm a software engineer, and buy is the better option than build yourself. Okay. Today we have 4 milestones to reach. First of all, a small background about the whole story, our 21st Century Lunch Bell. Then we start with a business problem, so to speak. And then we have some demos prepared here because we have our mobile food truck that we're going to try to detect with us. Hopefully, I say it in the beginning, we have here a Raspberry Pi, Azure IoT, Wi-Fi connected. Let's see how it turns out. We have everything prepared. It's always this flip-flop, coin flip decisions. Hopefully everything turns out great. If not, we have a backup here with our car, makes face API recognition, so we are good to go. Okay, the background, what's behind the story? Here you see a picture. Actually, for those guys that don't know where Graz is, this is the pin there, the location of our office, and this is the front door. We only have a subsection of this office. We are not that big of a company that we have this whole structure, but it looks nice on a marketing slide. And this was my view before I needed to move offices. So I sit there from my desk and watched exactly out of the window the front door. And every day at around 10:45, a nice car arrives here and offers great opportunities for lunch. So you're sitting there, watching on your right-hand side, seeing the car, stand up, walk like, I don't know, 37.6 seconds, and have this beautiful view, and then you can choose your sandwich for today. Then I needed to move my offices. This was my new view. Pretty the same like here. We also have some rabbits in the green side here, so it's familiar, but yeah, like 90 degrees on the other side of the building. No more direct angle to the car. How can I solve this problem? A possible solution would be create a recurrent event in Outlook. I have 30, 40 recurrent events each week. Not going to do that again. So no new calendar invite. The other option, I actually did this for a couple of days. Ping, that's our way in Skype for Business. I ping somebody. If he responds, I can ask a question. Ping a colleague and say, hey, do you see the truck? Is it there? I'm the team lead. I don't want to ask my developer guy every day, hey, I'm not so good. Next option would be stand up and have a look. Hey, come on, guys, be serious. That's not a real option here. Fourth option, use technology to solve the problem. And that's where the fun started. As a geek, you have to do something awesome. And then we have introduced a system called Mocadesimo. If you read these lines, they are, I think, from episode 2 from season 1 of the Big Bang Theory, where Leonard, the physicist, talks to Penny, the waitress, and he goes the way like this, okay, you're a waitress, so you act like a carbohydrate delivery system, serving food. What we created was a mobile carbohydrate delivery system monitor, hence Mocadesimo. So a little bit of nerd speech is always there. What or who is this fellow? You see here some red foam. Actually, it's the same hardware that is running this Raspberry Pi here. a Raspberry Pi connected to our local area network and taking pictures, uploading into Azure. Azure Cognitive Services recognizes the car or not, and then pings us in Teams, runs capability, says, okay, it's ready for lunchtime. The Teams team called it the dinner bell. Yeah, it's for lunch, it's not dinner, but come on, then in Seattle, it's a different time zone, we get it, but we're working on a better marketing with the Teams team also, that they get it, it's a lunch bell, not a dinner bell. So the guy sits there, actually on the place where my colleague has his workplace that I use to ping each day. So right here in this window. And the architecture is as follows. We have here a Raspberry Pi with a camera module inside, so everything built in Raspberry Pi stuff. You can order anything on Amazon for, yeah, here it's the euros actually, 37 euros for the Raspberry Pi, 18 euros for this foam thing that you have something like a stand. You can also use these Legos from China to build it on your own. Then you have the camera for 30 euros and a normal SD card just to run the Raspbian part there. What's running on the Raspberry Pi is Raspbian chassis. This was back then needed because the Azure CLI only worked on Raspbian chassis, not on Stretch. You need, of course, to be connected to the internet. Raspi still is a command line tool that takes images on a Raspberry Pi or on any Linux machine. We choose to run it on Linux because with the Azure or the Microsoft offering for Raspberry Pi, you can't do the same thing with imaging like with the Linux toolset, because you will see it's like, I don't know, 33 lines of shell script on the Pi, nothing more. So really, really tiny. And you can do a lot of things there. For example, mogrify and cropping the image, because I think it has an 8 megapixel sensor at the camera. It makes images with up to 3,000 pixels. So we crop everything before we upload it to Azure because we don't need the whole surrounding. And that's also a one-liner in Linux. And then you have the Azure CLI, the command line interface for Azure 2.0. Right now, it also runs on Raspberry Stretch, the newest version. But back then, it only worked on chassis. And curl for calling the Azure function to run the system. And this is actually everything in terms of code running on the Pi. So when you see there, you have some variables where you say, okay, this is our storage account, because what the Pi actually does is it makes a picture in line 12, crops it in line 15, and then we log into Azure to our blob storage, upload the image in line 21, and then we call an Azure function that says, okay, I have something for you under this URL in the Azure blob storage, go have a look at this image. And this script runs in a cron job every minute starting by 10:40, 10:45, something like that, and tries to detect the car. Combined behind those technologies, we have the blob storage, where all our images are stored. The Azure function, you can also connect the Azure function basically to the blob storage that is triggered every time you enter something in the blob storage. But yeah, we don't want it to start something connected already. We wanted to beat the trigger on our own, so you can start also with different images. Then you have a custom vision API. This is the AI part of the problem, and some storage tables, because we will show you. We then connected a bot to it, so you can ask, is the food truck already there? And all started there to get more data into the system. Actually, this is just the blob storage. For those that don't know it, it's the Azure Storage Explorer. You connect it with your credentials, and then you see all the images. You have different options. I could go for a blob storage, for a queue, for tables. Those are our test tables and production tables, but basically just storing the images there. We also then created a communication site in SharePoint with the same images. I think we are now close to 5,000 images, starting actually, I think, close to a year around last year. In the beginning of June last year, we started the whole thing and have all the images from each day in SharePoint and in Azure, just to have enough images to train the stuff. Then an Azure function that basically does the magic with taking the image, calling the custom vision API to our model, getting JSON back, and then rings the lunch bell or not. I will just run you through those points because the slides will have it all afterwards, and those things change like all 3 or 5 weeks with the next version of Azure Function Tooling, so it's not that accurate. The important part is that you have a custom vision API endpoint. This is a training model where you take some images, upload them to Azure, and you provide your own tags. We will show you that afterwards in the live demo, but basically you create an image classification system, and then you just use HTTP endpoints, point to an image or upload an image, and the API gives you back the probability of the tags that it recognizes on the image. That's the thing that detects the car, actually. And then we used as first Microsoft Teams, just a plain connector to ring the bell. We now have a flow that we start, that we can also ring the bell in Skype for Business. With Flow, I can connect you to an SMS service. I can send you a text, whatever is possible or reachable within the call of an HTTP call, basically. OK. This is, for example, a screenshot from the Custom Vision API. Back then, it was still in preview. It's since the build timeframe this year, you can already use this service also in production. And basically, you have here iterations, because you can train the system with more and more images, create new iterations, and then have an endpoint to test, a quick test, or retrain when you provide new images. Right now, we have in the model, I think, 500 different pictures that provides the model with the basic data, and we update it each month, each quarter, to have the newest pictures also, because we will see afterwards the front door looks different in May than it looks in November. In Austria with the snow and everything is gray, and then the probability went down, so we had to adjust our training model behind it. Yeah, the fun part was how do you come to this conclusion that you can use the Custom Vision API, and how do you test the API properly? I had the idea of detecting the food truck on my own, using my computer vision background, do the maths on my own, gradient detection, getting the car, and it was like, okay, it would take me, I don't know, 3 to 4 months, the whole summer, to do it by hand. And then last year around build, there was this preview of the Custom Vision API, and they say, start with 30 images, and you're good to go. And I bought the Raspberry Pi, and I was back home in my kitchen, and put there 3 different bottles of wine, taking 30 images of each bottle of wine, and then I said to my girlfriend, put a random one, I will try to detect it. 99.2%. With like 8 megapixel picture, the bottle that small, and it detected it immediately. Next workday, we already took pictures from the car, and it worked like a charm. So no need for do the math by your own. And the funny thing is, be prepared to understand prediction results. But because for us, it's clear, the car is here, so it's true, or it's false. It can't be both. That's clear for us. The system has no idea about this. It's just a tag. So if you combine the probability, you can go above 100. And the first day you see that, it is okay, the car is there to 60%, and it's not there to 50%, and you do the math, and it's like 110% probability? Something is odd. Yeah, it's over here, because it's just a tagging system. It's not mutually exclusive. It doesn't work this way. It took me like, 3 to 4 days, and I was so close to write a hefty email to the team saying, you did it all wrong. Thanks God I didn't write this email, but it embarrassed me. Okay, so the overall architecture again is the truck is here. We have our Raspberry Pi that takes an image, uploads it to Azure Storage, and then the Azure function gets triggered, makes the call to the Custom Vision service, and afterwards, basically, we have it in a storage table, and you can connect different systems to it. The easiest one is just our Teams connector that is triggered directly by the Azure function, but we are working on a Cortana integration, Alexa integration. It's not that hard, because we have a table that says the car is here. So a simple select query is entry for today, does it, so I can easily connect different systems. Okay, I'll hand over to Stephan. He will give you an introduction on bots and cognitive services.
Well, it's loud, isn't it? Now, coming from the AI point of view, you may want to ask yourself, how do we do it? How do we integrate bots within this solution? And this is what I'm going to tell you now. But first of all, let's start with the evolution of computers, and IT. I guess every one of you knows back in the days when I wasn't born in the 80s, there was like these normal desktop PCs where you had to go to your PC to do something on your PC, and the things you could do, they were rather limited back then. Coming in the 90s, there was the internet hype, so you could search for things in the internet, users could visit websites, but this wasn't also not, is not that usable as it is now. And in the 2000s, there was this mobile boom, everything was social, you had your apps downloaded within your app stores. But what is actually the future, or what does the future hold for IT or computers in general? And we think, or the vision of Microsoft is, it's conversational. So you don't have your apps, you don't have your, it's not about mobile or it's about desktop, it's about conversations, talking to devices like they were humans. And therefore, you have this bots stuff within Azure or within any big company's ecosystem, which is pushed out rather fast right now in order to bring humans to communicate with those devices in a natural way, not like clicking here, clicking there, doing this task, but having bots act like humans in order to make it more human interactive. And therefore Microsoft, or the Cambridge dictionary has come up with a definition of what is actually a bot. A bot is nothing more than a computer program designed to have a conversation with a human being, especially over the internet, of course. And it could happen via written text, could happen via vision, things like images, like videos, or it could happen either, as Tommy mentioned earlier, what we're building right now, via speech, spoken language. So these are the three main pillars for communication with a bot. And therefore, I want to tell you a bit more what a bot is. Is an app which performs automated tasks. If you look at it on a general way, and it solves the user's needs in the quickest way, not like websites or intranets or apps which may not be that usable or user-friendly as they should be. So a bot should always be designed in order to solve the user's problem in the quickest way possible. And what makes a bot great? It's not about how much AI a bot has. It's not about how much natural language it offers. And it's not about whether it uses voice or not. But it's about how you design. Yeah? It's about how you design the bot, and in order to solve the user's needs, as I said, in the quickest and most appropriate way. So bot, or bots in general, they're consisting of those four areas. So you always have a platform where your bot is hosted. For us, it's Microsoft Azure. You have always intelligent tools which are connected to your bot, like cognitive services for language understanding, for text analytics, for vision tasks. You always have bot builder SDKs, which is in the Microsoft bot framework, the bot builder SDK, where you can basically decide how you want to develop your bots, either C#, either Node.js, Python, or whatever. And you have always a REST endpoint. You can talk to your bot, or you can connect your bot to any other system. So basically, as you can see here, it's nothing more than an app or a web service you can call or consume. And Microsoft has come up with the bot framework. And the bot framework consists of channels. So these are the surfaces you deploy your bot to and your users consume. So you can deploy your bot to either Teams, Skype, Facebook Messenger, Slack, or any other popular channel users may use. Or you can integrate your own channel if you want to via these APIs. And then you have your, on the top, you can see it, you have your cognitive services, either for text understanding or language understanding, for knowledge management like Q&A databases, for vision tasks in order to have the bot being able to interpret an image, and so forth, or search APIs like Bing search, academic search, or whatever. And then you have your platform, which is on the bottom, as I said, the Azure Bot Service, consisting of the Bot Builder SDKs, where you can then basically decide how you want to develop your bot, as I said, .NET or the Node.js way. And you can also, apart from that, not only host it in Azure, you can host it wherever you want to, but you have to register your bot, at least in the Azure ecosystem, in order to get the Microsoft IDs, in order to have a unique bot directory. So how do you actually model a conversation? The most basic conversation model is Q&A. So you have FAQs with predefined questions, predefined answers. Your bot can ask the knowledge base, hey, I got this question from a user, do you have an answer to that? And the bot will either respond with an answer or respond with, I don't know the answer yet. And this is the far basic implementation approach for starting with a bot. Then you could go a bit further and design flows and forms in order to have like a dialogue, a basic dialogue management within your bot. Or you can really design dialogue. So you have, for each intent the user may ask a bot or may interact with a bot, you have a dialogue, and you can then guide the user through that dialogue within the conversation. And of course, the one with the most implementation effort is bespoke, like spoken language and designing the conversation for spoken language then. This is like the master class.
Let me jump in here for a moment. Do you know the Q&A Maker webpage? You can start building a Q&A bot without one line of code. You just enter questions and answers, and then you hook it to Teams or Skype for Business, and you can start with a bot. And this is actually our way we do it in the company, where, yeah, right now a lot of clients come, yeah, we want a bot. It's the newest buzzword, basically. Most of the times they have no clue what they want. They just want a bot, and when you ask them, what do you want to realize it, or what is the business case behind it? Yeah, we want to chat with the bot. Yeah, but what's the reason for using it? And we ended up with using the Q&A template, just with some basic question answers to justify more investments in development side, because you then have a minimal viable product with the Q&A bot, go to their customers, go to the mobile stories. Do the users really use it in their mobile devices? Do they use it on the web page? Is it really a way that the company ticks to use this conversational style? And when then they say, okay, we want the bot to move forward, we want new and more features, then we start implementing the stuff. Every line you don't write is a good line. You don't need to maintain it, you don't need to update it, it's the better way. So start on the easy side.
Yeah, that's right. And if you start with Q&A, it's basically a matter of minutes to get to the Azure portal, click add new bot, and that's it. Fill in your questions and answers, and you're good to go within an hour, and you have your bot up and running. And you have a couple of conversational mechanisms for a bot. Of course, you can have your bot only text only, so you give textual input, and the bot responds with a text. You can also include, as you can see here, media like pictures, like cards for more pictures and more information with buttons. You can respond via the bot with a video, and basically the Microsoft team is right now developing more and more, or putting more and more rich media or rich attachments into the bot service in order to have a bot not like, oh, it's just like text to text, but it's also like you communicate with your peers on WhatsApp, on Facebook, with images, with GIFs, whatever, to make it more human readable.
And since last week, you also can add an attachment in a one-on-one chat. So you can add a document to a bot, and then the bot can take it and interpret the things that inside the document. Translation services, getting sentiments, entity extraction, everything possible with just providing an image and enhancing the conversation this way.
Yeah, and it's based, let's go a bit back. It's based on the channel which supports all those things. So not every channel supports all those like rich cards or adaptive cards or images. So it's depending on the channel you deploy your bot to.
Yeah. They're actually called Office 365 adaptive cards. You can't expect Slack or Facebook to implement this interface. Yeah. You have a different level of integration of the services. With everything non-Microsoft, expect basic conversations in the text form, so strings basically. But within Microsoft, the vision is clear that every service uses Office 365 adaptive cards, being a team connector, is it in an Outlook mail, is it Skype for Business, is it Teams, everything is running.
Cortana.
Cortana is running in this direction.
And that's pretty neat because you don't have to deploy or develop your bot for all those channels. You develop it once, and it runs in all those channels the same, with the same code back then. And of course, bot lives or needs to be improved continuously. So you have like basic Azure instruments like application insights in order to gain those monitoring and metric events. You have to have a look at, and you have to check all those things continuously. Even with the cognitive services, you have to retrain your models in order to make it more understanding the inputs from your users. So it's not developing the bot once, putting it to a channel, and that's it, like you do it with a web page or anything else, but it's a continuous improvement phase. And as I said earlier, you can use or you can make use of all those cognitive services within your bot, depending on the use case. So you basically have vision, knowledge, management, speech categories, and within those categories you have different APIs you can make use of. You can combine them, but for bots, you basically may use the language understanding intelligence service in order to being able for the bot understanding the intents the user has. You may use the text analytics as well to get the sentiment of the input or of the questions from the users. And as we said earlier, Q&A maker for starting and building up knowledge bases.
Yeah, and then if you go one slide back, on the right-hand side, you have this category called labs. That's basically the new word for preview. And a service is designed inside Microsoft that the team says, okay, I want to have a new service for cognitive services, a new Azure offering. They start in the lab phase, and in the lab phase, they don't need to have a business case already here. So they don't need to know how is it work in terms of subscription, how the payment should be proceeded. So they focus on the tech, but they only have a certain amount of quarters in the year that they can be in this state, and then they need to make it clear, okay, how do we earn money with this service? And most of the times, some insider information, those lab projects can't go further not from the technical part, but from the financial part. They don't come up with a business reason that is feasible, so they shut it down. The tech is mostly, of course, they are all geeks. There's a good tech focus, but these lab projects don't expect every lab project to really hit GA. It's totally clear that not all of them will hit GA. So don't implement this really in a proper use case. It may be down in the next year. It's not this normal preview beta and it will hit GA. It's not that.
It's not that way. What we have actually used for our use case, we have used the custom vision service for deploying our own custom vision model with the food truck. And basically what you have to do, you have to upload images, like Tommy said, 30 images, far enough. You have to train the model with assigning the text to the images in order to have the service understand, okay, this picture is bound to this tag and this picture is bound to that tag. And then you're basically good to go to talk to the REST endpoint and check or predict the tags from the images, from new images. And then, of course, same thing for all cognitive services or for all AI services, iteration is the key to success in order to make your models better and better and better while using them. And this is basically a picture from the Mocadesimo at our office, and this is the food truck we were talking about. So basically, each day, about lunchtime, the food truck arrives and stands there, like this. But we even have cases where our package carrier stands in front of the truck, and we're still having 98% probability that the food truck has arrived. We even have like a lot of people standing in front of the truck, and it's no problem for the service to detect the truck. And it's not a matter of how the truck is parking at our parking lot. It even detects that the truck is here when it stands like this. So the service is rather smart for detecting the actual food truck, and it's not. It detects every truck, but it detects just our trained food truck.
Okay. I will give you a short glimpse or a short view into what is behind those cognitive services. In terms of computer vision tasks, basically you have 4 different areas. What we are doing is image classification. In this example, we just say the deer is here. We don't care where it is, it's just here. Next task would be option detection. We can, if you have time, you can show it then with the face API, where we have a rectangle around the face, so we detect something, or we segment out something, and image similarity, we say, okay, this picture looks same like the others. But our case basically is like image classification. It basically just says, okay, I have an image and the food truck is present in that image. That's why it doesn't matter how the truck is arriving, how it stands in terms of the angle, it's just there. Before, you would end up building something like this in a computer vision model. When you look at this bicycle, you see here the gradients of the histogram, the different changes in terms of the colors that are used. Don't think just of an image, or the image basically is a matrix where you have in each coordinate the color value. Then you move it in different color spaces. It's not just that you and I, we only are able to see this one, but in terms of mathematical structure of the picture, you have the different color spaces, color rooms, and then you see here, okay, an edge detection of the bicycle, and then you can see, okay, basically, if you see this, you see the bike there. If I don't show you this picture, maybe some get it as a bike, most of us probably not. But with this preparation, it's easy. And this was the way for me, building a support vector machine and going in that direction. I want to do it by my own. What's behind in the cloud, it's basically a deep learning and a deep neural network where they have different areas where they focus in terms of detection. You see here low-level features. They just match if the same color patterns, the same line patterns are present in the images. Then they go to higher levels, look for corners, simple shapes, and then the first objects we see, like wheels or faces or windows. And this is behind, they don't speak openly about what they're using. You get an answer like, yeah, we use basically the scientific way of image recognition. That's the same answer you will get from AWS. It's the same answer you get for Google. They don't share their mathematical background there, but it's not that this is, the question is not you can do it on your own with Mathematica or MATLAB to build this system, but not within minutes, not within just throwing image in, tag it. This is the power of the cloud right now. The important part is you need the cloud to create the model. But the newest version is like that you can export the model to TensorFlow and use it on smaller hardware, use it on a mobile phone. For example, in the conference, they had a demo where they detected, I think, oranges and apples, and then you use an iPhone to detect the stuff, because the model is trained, and the trained algorithm can basically run on a tiny, tiny chip. This is this Azure IoT Edge scenario, where you have the cloud powering the model, but the local hardware, way less powerful, also can run the algorithm to detect the stuff. We want to build this also. I already ordered this Azure Sphere, this newest IoT device. It will come out in September. But we would need to recreate our project because we created our custom vision project before they allowed us to export it. And now I would need to make it new, but we will definitely do it, and we'll just run it on the Pi. So we don't need internet. You don't need to upload anything, just local detection, and you have the same result. That's the real power. This is the scenario where Microsoft is different from Azure, where Azure is different from AWS or Google, because they say, okay, you have this disconnected place. Another example is like a big ship with containers that isn't online every single weekend, but the intelligence technology maybe on a container is connected to the local area network from the ship, and the ship is only connected each 20 hours or 24 hours. But the device doesn't know that. It has this IoT hub on the ship and thinks it's online, and then it's fired. This hybrid online-offline scenario, this is where Microsoft has the main advantage over all the different cloud vendors, and this is what they're pushing heavily. Okay. Some points about language understanding.
So coming back to bots, in order to have the bot understand the user questions or the user inputs, you have to make use of a language understanding service, which is called LUIS in the Microsoft speaking. And basically what it does, if you look at this text, has the food truck arrived? It checks for certain parts within those sentences. So you have to define, first of all, your language understanding model. You have to define your intents, and you have to define your entities, and the entities are basically object and operation. And if you hit the service with a given text like "has the food truck arrived," it checks, hey, is there an object or is there an operation within those sentences? And if yes, basically spoken, it guides you to the correct intent, and afterwards you can have your custom business logic attached where you define, okay, intent 1, do that, intent 2, do that, and so forth. And for us, it's check arrival state is our intent, where we fire then up the device comments.
And this is the main difference about language understanding and just the Q&A maker. The Q&A maker just uses a sophisticated kind of pattern matching, and language understanding is really food truck arrived. In any sentence, it will detect the object, it will detect the operation, and tries to make sense of the whole sentence. And this is what language understanding makes more, you need to put more brain power behind it, because you need to create a model and create the dialogues, and the Q&A maker just works like a regex, basically.
And with this service, you also have synonyms for certain subjects or certain words, like not food truck, but just truck or whatever, or car would also work if you train the model like this. And basically what you have to do in order to set up such a language understanding service, you have to create intents, you have to create entities. So the intents are those things the user input the bot or the service with, like book hotel could be an intent, and an entity could be a location like Madrid, for example. Then you have to add your utterances, your examples to that service, like book a hotel in Seattle, book a hotel in Madrid, book me a hotel in 2 weeks in, I don't know, in Graz. And you have to add like 5 or 10 utterances. Then you're good to go to train the service. You can test it, you can adopt it. And you can add several other utterances in order to, make it better. And after you've tested it and refined it, you're good to go to publish the app. And basically what it does then, you have a REST endpoint you can talk to like any other of the cognitive services in Azure. So where does the lunch bell ring in our scenario? Basically it rings in Teams like we saw earlier, We will see this in a demo as well. And it rings in SharePoint Online. And this makes me come to the demo. So Tommy will show you the live demo for the lunch bell or for the food truck arriving right now.
Okay, what we're going to do is two things. I will show you the system back home, but there is no food truck on a Saturday. That's why we have our own food truck here. And actually, Stephan did the preparation like 10 minutes before the session started. We took images with the car here and without here, and then we will see how it works out in terms of using the system in the model. But let's check out the stuff.
And today it's pizza, so.
It's again pizza day, like every Saturday the last weeks. What you see here is one possible solution in terms of how to integrate such technology to your workplace. We have here an internet demo of what we use back home, and what we are partnering is Valo. So you have a simple Valo page here. We tried to create some pictures for the speakers activity, what we did yesterday, for example, and how you create this bot back home with all the soldering and all those crazy things. But basically, we have here a simple chat window. And this chat window, I can start here, and I can say, he. Okay, welcome, I'm Ocodecimo. Here's a list of my features. We will focus on option 1 and 7 right now, because for the other options, I need to know how to connect those wires, and apparently I forgot. And I don't want to...
You didn't write it down anywhere.
Yeah, no documentation. Thank you, Stephan. This will hurt me back home. Oh, I know. But yeah, basically, we try to detect this way. So the idea is that you have this bot here. Then you can say, OK, press 1. I try it right now. It will take some time. I think we hit some, yeah. We have this Gemo gear with us for this whole year, because the session is like booked for 10 times already this year. And we always have the problem of the different Wi-Fis. And is it the conference Wi-Fi? Is it our own phone? What is working right now? And what is behind this chatbot is that we have here a chatbot running in Azure right now. And this chatbot is reaching out to an IoT hub. And the IoT hub called back to this Raspberry Pi and told the Raspberry Pi to make an image. And with all those times out and connection times, sometimes you end up with an image like this. Let's see. How do you open it? You managed it earlier. Let's try it again. It's the chatbot reaching out to Azure IoT Hub and then reaching back to this Raspberry Pi where the IoT service is running, firing a command line tool, making the picture, uploading it to the Azure cloud, and apparently something went wrong now here. But in the meantime, I will show you what we prepared already before. So this was us, the same bot now in Teams here. It's just a different channel, trying it like last week. Where you see this is what we're going to try to do today. We have the pictures here, and here's a picture without the car, and then we have the car ready. So let's see.
You should be good to go to try it again. The Pi went to sleep.
Okay. And if you want to prepare a session as the same one, be advised of calculating like 3 to 4 hours each day to preparing everything with the connections and backup devices and all those things. It's not that easy always. Are we good?
Nope.
So Stephan is here connected actually to this Raspberry Pi here.
Have you tried turning it off and on again?
Doing right now. But in the meantime, let's check out our launch portal, for example. Yep, it's the right tenant. This is basically one of the the pages we use to fire up. And you see here that we also use basic basic functions of C# to add a layer to the image with the tag here. This was a snapshot where they started to build up for conference for our offices. The image totally looked different this day, so we realized it in terms of the readability, what's behind it. But here, if I go to the site contents, I think this is one of the site collections with a lot of images. You see here we have 5,300 images in our track pictures. And I go there. I see the different images here, and we upload everything. This was one of the first training images I tried to train or to connect to the Raspberry Pi, because this is back home my window in the evening. I go somewhere, let's look at here. You see the different training pictures, a picture size, the car here, the car not here, the different probabilities we got back. Bulk edit, I don't want to. So every time, or we store each take, so every minute we make a picture, just to have these lists, and then we can go back over here and say, okay, what's the probability here? It's like 1, so it's pretty sure that the car is here. But the interesting pictures is then something like this, where the car is here and not here, and the probability is not right, so to speak. And what we're already working is something like that when you have this picture here and the system tagged it wrong, that you connect here an event hook, then you can say, okay, this is true, this is false, that you can retrain the model. Because the retraining is the part where the system learns again, and we want to make sure that end users are able to learn the system, or to train the system. It's not a technical problem. I can download this image, I can upload it to the service again and hit the retrain button, but this is not something an end user can do. So we want to be like in a self-service, and say, okay, I see the image, on Friday, for example, have half an hour time, look through all the images of the week. Is there something wrong? Because the human always knows it better than the machine in these cases, and retake it and then retrain it. So we have a new model and updated devices. This is like the self-learning system. It's never self-learning. It stays that intelligent the last time you trained it, but you can go there and have new inputs here. Okay, Stephan, how are you looking? No Pi? Okay. Then let's just look at the pictures from last week. You see here, one of the first cases is basically, this is the conference dish from SharePoint Saturday Madrid from 2 weeks time ago, where we did the same, where we have the same Raspberry Pi here making images. And then you see, okay, here's your test image, and the value was like, okay, the car is 0.05% here. So it's pretty sure that the car is not present. But still, some percentage always is there, because it recognizes the same thing like here, taking 30 images of just the plain table, and with the car and without the car. And then you say, okay, the tag that we are ready, because we are ready for lunch, or we are ready we are ready to detect the system, is like this. And then when the car is ready, we have 75% that it detected this food truck. This is actually the same thing we tried to do here. Let's just go to the custom vision API and show the system in this way. Where are we? Here we are. Because here you see the training images apparently from this room. The model we tried to prepare and to connect the bot with today. This was like 5 to 10 minutes before the session. The car not present here, or the car present here. And with this set of images, we also use just the command line tools on the Raspberry Pi to say, okay, let's try this out. make 30 images in 1 minute, store it somewhere, and then you basically go here and click Add Images. You drag your images there, browse for some files, take it, and then you can see if it works or not. And actually, this would be funny to try it with the test images from Zurich right now. Yep. Let's try it this way. And now we hit one iteration. Stephan once hit the training button, so we created the model already. And we can now create a quick test. And the quick test you can do with either an image that is somewhere out in the World Wide Web, just hit an endpoint, or you have a local file. And in terms of...
Would you like to eat?
Yeah. And if you have a local file with your test image, let's see. Yeah. And basically, we have the model now for Madrid, but the test image from Zurich, and it says, OK, to 97%, I'm sure that the car is here. So it's not totally clear for us what the system is using in terms of the mathematical values here. I assume it uses a lot of the color information of this yellow truck here to create this. Yeah. OK. Yeah, basically, this would be the demo case for today. OK, so if they urge us so to hurry up, go grab your lunch. Thank you.